Hey, this is a video recording of a talk I gave yesterday at a local meetup at the MLOps.community meetup in Amsterdam. And now I'm doing a recording of it because I got some nice compliments and I thought, hey, it would be nice to be able to share this talk with people who couldn't make it that evening. So that's what I'm going to do here. The talk was titled How I Use AI to Learn. And I talk about that because that's a huge part of my job. I work at Answer AI, which is a AI R&D lab founded by Jeremy Howard and Eric Ries. They're famous from, well, Jeremy's famous from Fast AI, and Eric Ries is famous from the Lean Startup. And yeah, my job there is to figure out what AI is useful for. And that means not what is impressive or what demos well, but what is actually useful in real work, real life. And yeah, that's what I want to talk about. Now, the obvious answer, like what is AI useful for, that people might give is to go faster. And yeah, I understand that. I have stuff I want to get done as well. But when you think about going faster, I want you to maybe rethink it a little bit in terms of also speed versus acceleration. Am I just getting a speed bump or am I continually going faster? Speed is how fast I finish one task. Acceleration means whether the next task will also become easier and faster after I finish the first. And a good workflow doesn't just increase my speed today, but it also increases my future speed. Now, let me give you a little negative example from a vanilla Codex workflow. So here I'm asking Codex to help me build a weather app that also recommends what clothes to wear. And it just starts building. And it takes 5 minutes for it to be ready. To be fair, I did put it on extra high thinking. But it really does a lot. Like it starts to look up skills for image generation. And yeah, if that happens, I'm going to sit back and relax for a bit. But 5 minutes later, I look and, well, yeah, I'm impressed. I'm excited because there's something that works, kinda. And that excitement is fun, gives me a kick, and that's great for a little toy example, but it doesn't really work in the real world. And not because it functionally doesn't work, but because I don't understand how it works. And that quickly becomes a problem, because if something's really good and exciting, I start showing it to other people. And those other people will ask me, hey, Rens, super cool, how does it work? And I have to say, I don't know, let me ask the AI. Then they say, can you also make it do this and that? Whew, I don't know, let me ask the AI. And if it gets really annoying, they start saying, hey, Rens, have you thought about these security concerns? And I say, I don't know, let me ask the AI. And that gets, and that means that my excitement quickly turns into embarrassment and frustration when I then try to dig into this code base and I am overwhelmed by the 700 lines plus in a JavaScript library that I don't happen to know. And that I don't happen to know it is no problem. But it's quite intimidating to learn a new thing if there's already such a big code base that you have to dive into, at least for me. The root cause, the failure mode, is when the code base grows, but I don't. The output exists, but the capability didn't transfer to me. I'm not accelerating. I'm just borrowing capability from the AI. And I'll be paying it back later with interest. This is known as cognitive debt, kind of like as a parallel to technical debt. And sure, sometimes it's good to take on some debt, right? There's some good types of debt, but I think that with the use of AI, we're living too much on the credit card. So the question is, how do we use AI in a way that our understanding compounds along with the work? And I've heard some criticism of this view. So here are some things that I've heard. No one cares about understanding at my job. All I do is write boilerplate code anyway. There's too much pressure to deliver quickly. AI will get better, so why bother? And if that's you, then maybe I want to challenge you or to help you reframe your thinking to go from feeling that you have a lot of delivery pressure to feeling your career pressure or maybe even your life pressure. Because if you keep borrowing from the AI's capability to just get the thing done today, then you're hollowing yourself out. And over time, you will not have much to offer besides what the AI can do. And that's really a pity, I think. It's better to learn things and become more capable and feel like, hey, I can do more than I could before. And that's not just from a career perspective, like that you can get a higher paying job and keep up your standards of living, but more importantly, like there's a life well lived type of pressure that I hope you will feel. And for me, that means that I love learning. And probably if you're this far into this video, you probably do too. And, I love watching TV and eating unhealthy food on the couch as much as the next person. But the next day, I don't feel that great about it anymore. But I do feel great if I've done some hard training for my run, and in the end of a multi-week period, I can run a little bit faster or a little bit further, and I feel like, I worked hard for something, and I've become more capable. And that's the feeling that I would like to keep having. That's the type of feeling that I want AI to help me get more, not less of. So that's what this talk was about. AI workflows where you grow too. Not rejecting AI, not saying I'm going to do everything by hand, but getting the AI to help me to grow. So in my work at Answer AI, I've seen 3 things work very well, and that's what I want to talk about today. So those 3 things are working in small steps, in a live environment with live state, and seeing rich outputs. And I'm going to demonstrate those 3 principles with tools that we build and that you can use too. But they're not the main takeaway. I really hope you just take away these principles and maybe get inspired to use them in your daily work. And if you find a great way to make those work in another tool, then I'd love to hear it. So, make sure that you reach out to me if that's the case. So, small steps. I want to start with a picture. You have seen this picture. Claude Code, you've been typing, you set your specification, you press enter, and then 3 things happen, at least to me. The first thing is that I start leaning back. I'm like, okay, now I can relax. The next thing that happens to me is that I close my eyes, cross my fingers, and start praying, like, please work, please work, please work. Almost like I'm in the casino watching the ball in the roulette wheel spin. Now, if it even takes longer than that, like I put think on extra high, then I start cycling through Reddit and Twitter and Hacker News again, because I'm weak. And if I'm doing something cognitively hard, I'm learning something new, then I'm looking for any excuse to stop. So yeah, that's the problem with working in large steps. They take me away from thinking about the problem. The other problem with big steps is related to some knowledge that we have about pull requests. So we know that if a pull request has very few changed lines, then they get only a few comments. Looks good to me, I understand everything, let's keep on going. And if a PR has many lines changed, they also get a looks good to me review, but that's a review of much lower quality, because then the errors don't really get caught. And more importantly, the understanding does not get transferred. So if you made me a super big PR, and I would be like, okay, I can't review this, I would say, please try it again, because I just don't understand this. But in small PRs, your understanding of making a PR gets transferred to me as the one who's reviewing it, because, I understand it. I can oversee what's being changed. And I think the irony with working with AI is that with AI, all of a sudden we are accepting these 600-line change requests. And even worse, it's not the transfer not staying stuck with one person and not being transferred to the other person with a big pull request from human to human. Now the knowledge is not even transferred from a machine system to a person. So now nobody knows about how the system works. So yeah, small steps, they make sure that I don't get distracted, I stay on task, and I actually understand what's going on. Now, I want to demonstrate this to you using a tool that I use every day. It's open source. You can pip install it yourself, pip install shell_sage, and then I will show this in the terminal. So here I am in the terminal, and I realize that I've made a mistake. And I'm telling shell_sage about it. I made a huge mistake. I accidentally committed on the wrong branch. And shell_sage can already see that I'm on the main branch because it actually sees what's on the screen in the terminal. And it's asking me, okay, how many commits did you do? And what branch did you want them to move to? And it suggests a command to run. It didn't run this itself. No, it's giving me the chance to run it manually. So I use a keyboard shortcut to run this, and now we both see the result. And I'm already learning, hey, git log one line is a nice keyboard shortcut to see my history. And now I can say, those last 3 commits should go to a new branch. And again, shell_sage sees all the history and can suggest me a change. And it tells me, okay, so you can make a new branch with this new name, and then you can just remove those 3 commits from the main branch. All right, I feel comfortable doing that. So I, again, use my keyboard shortcut to get the first branch. And just to show you, I can now easily rename it just a little bit how I like it. So these are like ways that I'm being facilitated to work in small steps. And now I can do a git reset. So I use the other keyboard shortcut to get the second fence. And now I can say, let's check that worked. Okay, so let's do that. And now we see that the main branch has these commits, and now it's here is the main feature branch. What do you know? We have a success. So yeah, that's a little demo of shell_sage. So what do we see? The AI proposes a change. I can adjust it. I can run it. And together we observe it. And the principles that make this workflow work are, there's a couple. So the first of all is that it's there when you need it, using existing tools. I'm already in my favorite terminal app, and I don't need to switch screens to Alt-Tab or to copy-paste or to re-explain myself. You can see already what's going on in my environment. That shared context creates shared understanding. The code fences that I run are really better than tool calling in this sense, because me being hands-on with it, touching it, helps me internalize the commands better. It helps me learn. Otherwise, I would forget these commands again the next day. The other thing that helps is that I put a bit of a system prompt in there to really slow me down and to explain things to me. And if you think that would be useful to you, you can go to my personal website. It's rensdimmendaal.com. And there's a blog post there that has the prompt that I have here. But honestly, the prompt is the least impressive part of this setup. Now, let's go to the next part, a live environment. And I'm going to illustrate this one with a little anti-example again. So this is again in Codex. And I'm going to ask it to help me learn about polars, a data frame library in Python. And what happens is that Codex starts looking around in my hard drive. What do I have over here? There's nothing there. It's just looking at my Python environment. What packages do I have installed? It makes a new folder. It makes a new virtual environment. It makes a 100-line script, and it tells me, hey, here's a nice script, and go and play with it. and I will have to switch screens, change to a new app, and there's a lot of friction for me to go and explore that, and then go back to Codex again and say, hey, this is what I don't understand, or this is where I'm stuck. And even worse, it didn't even ask me like, hey, what do you want to learn? It just gave me a bunch of exercises that it could have shared with anybody. But I'm willing to bet that I would more benefit from some exercises than you would. And it would have been nice if it had maybe asked a little bit about what my learning goals are or what my existing knowledge is. So the fact that we need a live environment to work in and that we need to be able to see what's going on is not a new idea. One of the great thinkers in computer science today, Brett Victor, says, creators need an immediate connection to what they create. That's his principle. And the reason why he says we need this as creators is because discovery is essential for creation. You can't discover what you can't see. And that's why we've always had like so much fun in the REPL, like the Python or IPython REPL, and Jupyter Notebooks. They are a very live environment where you can immediately see what's going on. That type loop is what makes exploration possible, and that's what facilitates creation and learning. But now with AI, we need to rethink this, because it's not just you and your code anymore, but there's also your AI. Your AI also wants to see your code. And you want to also be able to change your AI as it is working with you. So that's what I'm going to show you next in Solvit. So here I'm in Solvit, and Solvit is most simply explained as if, let's say, Jupyter Notebook and ChatGPT merged. But there's a whole lot more to it, but maybe this is the best start. So here I have my text editor, and here we'll have the messages. So here I'm writing a prompt. I'd like to learn about polars using that famous penguin dataset. Can you help me? And instead of immediately jumping to conclusions, it's going to ask me some questions. So I'm expert in pandas, and yes, it's installed. You know, and that's just as fine as it doing all that research by itself. So here we go, we got a code fence, and with a press of the button, just like with Shell Sage, I can extract it and take a look. And now I can direct, let's see what Solvit says. So hey, what does the output look like? Yeah, we see it over here. Okay, and I can say, okay, that looks interesting. I would be curious to learn how to find all the rows with null values. Can you maybe tell me about that? So instead of Codex coming up with lots of lessons, directed by my curiosity, because I'm in this live environment and I can see the results, I can direct where my learning has to go. And that's a lot more fun than just following a bunch of sloppy exercises. So, and now I'm learning about Polar's idea of expressions. So you do df.filter with an expression, and the expression describes the per row condition. And the two building blocks that I would be interested in is the column name and is null. All right. And you can also do PL all horizontal, which does row-wise and across whatever expression you give it. Okay. So I'm a little bit confused. So I'll do a small step first. So df.filter, PL call sex is null. Okay, so we did find all the rows without any data for the sex. Okay, that worked. But I'm not sure about that all horizontal. Okay, so we have call or horizontal A, B, C. Okay. All horizontal, this one, and that one. Oh, okay, so you give multiple arguments to the all horizontal, and then only if it's true for all conditions. But I don't want all at once. No, no, no. I want if any is missing in any of the columns. So I want to find the rows with at least one missing value. But I'm already learning new stuff, right? I'm learning like, hey, all horizontal does something for all of them. Oh, okay, there's also an any horizontal. That's nice. And I'm also learning, hey, this is all null. Okay, let's see what that does. So df.filter pl all is null. What went wrong here? Okay, so there's pl.any horizontal. All right, like that. Cool. So I learned some new things. Now I want to show you the next thing. So, let me recap first. So what we saw was that because we have this live environment, I could direct my learning much better, and I could the AI could also guide me better in my learning. What I want to show you next is how you can use Solvit to also let the AI inspect your state. So here I'm telling it to find all the methods of the data frame. If you would ask this to any other AI tool, it would most probably either search the docs online or start looking in the Python files in your virtual environment. But because we have this live Python REPL, it can just literally call dir on your object with a tool, and it can get a live overview. And that's great for a dynamic language like Python, because any method might be patched on later, and in the fast AI and fast core libraries that we make at Answer AI, we do that quite a lot. It's like one of the beauties of being in a dynamic language. But let me explain what this tool call actually is. So here we see this tool simdir being called. And what do you know? Simdir is just a Python function with which has been made available to the AI as a tool. And I want to show that to you. So here I can, for example, make this little silly function to add two integers. Sum of two ints. And it's this easy to say use add to make a new tool for the AI. So I am in a live environment also with the AI. I can define new tools for the AI with very little friction. And that's very exciting, I think, because I've done lots of prototyping, tested out little ideas in small steps, because I have an AI that I can actually modify with the Python functions that I write. So, and here you see the tool being called, and we see the result. So now I'm going to take it one step further. I'm going to give Python access to the entire Python kernel that we're currently in. I'll do that with a little demo. So from save by run import run Python. By run equals run Python. So we instantiate the class. Now we say A equals this and B equals this. And now I can say use and by run to calc A divided by B, whatever. And now Solvit can use straight away the environment that we're in. It didn't need to redefine these variables. Because we're in this shared state, it can use those variables. And this is really powerful. I use this all the time to let Solvit work in the environment that I am in. And we really catch errors that way very quickly, because it doesn't have to guess about what the values of any symbol is. So what did we just see? A shared canvas instead of dead code. In the dead environment, The AI is by itself creating a new virtual environment and scripts, everything from scratch, not checking what I actually want to learn. And my curiosity cannot drive the learning. In a live environment, that can really be done a lot better. In the dead environment, AI guesses the values from the docs, and in the live environment, it can actually inspect the live kernel that we're in. In the dead environment, the AI writes, and I'm just watching, and in the live environment, we collaborate in a shared kernel, in a shared REPL. So now let's go to the rich output example, and we're going to rebuild the weather app that we made in the start of this video. So I'm going to do this as a recording, and I'll just pause whenever we have to. So the first thing I want to say is, like, you don't always have to learn everything from scratch, right? Like, you already bring a lot of knowledge with you when you're working. So sometimes it's okay to just tell Solve to do things for you, but then make sure that you still keep working in small steps so you can still review everything. So what I'm doing over here is I'm asking Solve to help me make that weather app. Solve is asking me what kind of app, what weather data source, and what's your experience level. And I'm very briefly just explaining it. Well, I want to make a fast HTML app with OpenMeteor as the API, and I am quite experienced in fast HTML. And it's giving me some code to do the weather recommendations, and with the keyboard shortcuts, I can quickly extract them, run them, evaluate some demo results, so that even though I'm looking at AI-generated code, I still am very engaged, understand the lines, and see visually, like, hey, these outputs are correct. We're using the small steps and live environment. We continue, we get a function to recommend clothes based on the weather. And here, actually, I got some results that I didn't fully understand. There's a line, if code in, and then a tuple of values, and I didn't know what those codes were. So I stop, and I ask questions, straight when it happens, not a long time later. And then Solve can explain to me that these are like standard weather interpretation codes, and that they have different meanings, and we can use them for our clothing recommendations. Now, the next thing that happens is that Solve says, hey, let's go and build the app. But here come the rich outputs. So I'm going to say, no, before you do that, please respond in your response, return an HTML iframe that mocks up the UI, because we're in a web app. So the output of Solve can be rendered as HTML. So what you'll see here is that Solve will mock up the UI in its response, no code, no extra steps, and we can already see, like, if this direction that Solve wants to go into is something that we like. I did not like this design, so I said, I like my slop more neo-brutalist. And Solve tries again. And see how, like, being able to see this rich output without having to switch screens or save something in a file is very convenient. So now I'm happy with this result, and something's very quickly happening on the screen because it was recorded at twice speed. But I'm pasting in the relevant docs. I'm pasting in the docs that I know to be of high quality. You don't always have to let the AI search the web to find the right docs. It's fine if you know, hey, this is the gold standard. So I'm telling it, hey, this is how you work with fast HTML in a Jupyter-like environment. And Solve reads the docs and is happy to propose a mock-up or a prototype of the app. And it's giving me quite some code now at once. But it's already giving it in separate code fences, if you can see it. And that means that if I extract with a keyboard shortcut this code, they all become separate code messages. And I can run them one by one and inspect their results. And here's the cool bit. So the live app is now running in a code cell. So I did not have to switch screens. I did not have to do anything special. I'm using this app here live in my environment. And I can actually run it and see the actual results. And now we can go to a new tab, to a real URL, which you already get from Solve, which is running that same app. And that means that you can go in very small steps to create a live output that's richly rendered, that you can also immediately share with your friends and get feedback from other people. So I think that's really, really nice. I've made lots of little apps and shared them with people around me and gotten fast feedback. so I could iterate rapidly. So yeah, that's the demo of rich outputs. And yeah, you might now think like, that's pretty cool. And okay, so if I want to learn some Python library, or if I want to make a web app, I should maybe give Solve it a try. But I want to remind you of the thing that, hey, it's mostly about the principles, and I think that these principles can also be applied in other tools, even though I think Solve it is pretty cool. The other thing that I want to indicate is that not all learning is coding. Book authors do research when they're writing their book. Eric Ries used Solve it as his workbench when working on his latest book, Incorruptible. Students are studying all the time, and that's not all code. Jeremy's daughter, Claire, is learning calculus using Solve it, loading in the book into the Solve it dialogue, asking questions, trying things out. And we actually have a sister law firm at Answer AI. So Answer AI is the R&D lab, but we have Virgil, the law firm, where we have dozens of lawyers using Solve it for their lawyery tasks, contract drafting, a bit of data management, emails. And that means that they are not, that doesn't mean that they're using Solve it to like do everything for them and they don't have to think. No, just like with how I showed it with coding, it's helping them learn more, become better, and accelerate so that they get faster and faster over time. Here's an example of how I learned a little bit about a paper in Solve it. So here I'm loading the Attention is All You Need paper, and the first time I read this paper, I was confused because in the paragraph below it, it talks about these Z representations, and I didn't see them in the figure. And I asked Solve it, hey, where are they? And Solve it can see everything. So the images, it also gets. And it explains, no, it's the arrow that goes from the left-hand column into the right-hand column. And I can take a look, and okay, now I get it. And because we're in a coding environment, I can still then say, hey, can you give me a little coding mockup of this model so I can try it out? And this is really, really awesome because I can go from reading a paper to asking questions about it to hacking on it in super small steps. And that's an awesome feeling for learning. So to wrap up, learning is building. If you're learning, it's really useful to be able to build something because that's how you really learn something. And building is learning because you're always faced with questions about stuff that you don't know yet. And most importantly, learning is living. It's a core quality of what makes life worth living. And I hope that you use AI to increase all of these things rather than let them diminish. Now you can do that by trying our stuff, by pip installing shell sage, for example, or by going to solve.it.com/signup, or by building your own tools, or by bringing these principles into your own tools that you already use. And if that's the case, again, I'd love to hear your story. This was how I use AI to learn, and I thank you for paying attention. Bye-bye.